Okay guys, so I just want to quickly talk to you about the universal rule for elliptical tilt, which is in your circle notes under week 3. And it's to help you when you're constructing your candlesticks. So when you draw a candlestick, so under the definition it says the widest part of an ellipse is always perpendicular or measurable 90 degrees to the cylindrical axis that is understood to emerge from the center of the foreshortened circle at an actual 90-degree angle. Now I know that sounds kind of confusing, so I want to sort of clarify what that means. So if you draw the center axis on your candlestick, and remember the ellipse at the top of your candlestick is very compressed. So you have this ellipse up here, and then maybe you have this, I'm not looking at a candlestick, I'm just going to kind of make this up. But the idea is you want to keep it symmetrical. Your ellipses are going to get a little deeper as they get away from the horizon line, which would probably be about here. So to review on that a little bit, at eye level, or the horizon line, I'm going to label this, horizon line is eye level. The top of a cylinder would be just a straight line. As you move away from the horizon line, let's take a look at what happens. Your ellipses are very compressed near the horizon line. They're going to start to open up a little bit as you move away from the horizon line. You're going to get a little bit deeper, 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 deeper. So near the horizon line, very compressed, but as you move away from the horizon line, as you're looking down at the bottom of your candlestick, it's going to open up a bit. So this is what happens with a cylinder. So the same thing's going to happen on your candlestick. You're going to have, there's like lots of bumps that happen in here. You're going to keep it symmetrical. So the right side equals the left side. Keep that center axis in there. Make sure you draw that center axis. There's like an upside down light bulb, I call it, on one. I don't totally remember, but this is getting a little bit deeper in my shapes. Maybe there's another little bump right there, and maybe the base of the candlestick is somewhere around here. Now again, I'm just making this up. I'm not looking at a candlestick. So then now this is the drawing position, by the way. I think you guys have reviewed this already. This is your writing position. This is your drawing position. In that drawing position, you can lightly indicate things pretty easily. And then you want to go to your drawing position when you go to do details. But you want to keep some of your drawing covered. Try to find a piece of paper to keep your drawing clean. Otherwise, your hand is going to just smudge everything on that page. So you come in here, and now I'm going to come in and vary your line weight a little bit. So I say pressure, release. Maybe there's another little lip back here on your candlestick. You see some thickness happening there. Pressure, release, pressure, release. Make sure your ellipses are wrapping around that thing, and make sure it's symmetrical. Pressure, release, pressure, release. And now your ellipses are getting a little bit deeper as you're coming down into the base. Again, this is totally made up. Not totally. I mean, some of these shapes I'm familiar with from the candlesticks on the table that you should hopefully have in Brightspace. You should have access to. Pressure, release. Maybe this is vertical here. Pressure, release. Now, at the base of every object, there's a little cast shadow right there. So that's going to be a little bit darker. But that's how you keep your candlestick upright. So if you were to do a candlestick without that center axis, by the way, when this talks about the widest part of an ellipse is always perpendicular, meaning if you were to complete this ellipse, for instance, this is the widest part of the ellipse, it's perpendicular or a measurable 90-degree angle to that center axis. Same with any of these ellipses. This is the widest part. It's 90-degree angle with that center axis. So if I complete this ellipse, the widest part is 90 degrees perpendicular to that center axis. If you do not use the center axis, what might happen? I've actually seen this happen. Your candlestick might tilt over, or maybe you'll start making ellipses like this, and maybe you make another one this way, and it's not exactly symmetrical. So all these weird things start happening, and you kind of look like you have a drunken candlestick, right? Because you have no center ellipse. Central axis coming in here. The widest part of these ellipses are not perpendicular. If you were to put that center axis in there, this is no longer 90 degrees, right? Here's the widest part, not 90 degrees. So this is what can happen. Your candlestick can also start leaning over, tilting. I've seen all kinds of things happen. So if you have a ruler, use it on anything cylindrical, add that center line, build your candlestick based on this principle where ellipses get more compressed as they get toward that horizon line, and they start to open up as you move away. Some of the other things that are in that list of circle notes, the center of an ellipse. So here's your ellipse. The center of an ellipse is located where the major and minor axes of the ellipse intersect. So here's the minor axis of the ellipse. Here's the major axis. There's the center. Okay? And that's pretty much all I want to talk to you about at this point. So I want to make sure you understand how to construct these candlesticks before you get started on that first assignment from me. It's assignment number 6, where you're building 5 boxy things, 5 cylindrical things, one of which I'd like you to try to do that candlestick. It'd be really great. All right, so can't wait to see your drawings.